welcome to this lecture on vector calculus. In this video, we are going to solve a problem on unit normal vector. So, in the first problem, find the unit normal vector to this function x square plus xy plus z square equal to 4 at the point 1 comma minus 1 comma 2. So, we want to find the unit normal vector for this function. Okay. So, first, the unit normal vector will be denoted by n cap. The formula will be gradient pi divided by norm gradient pi. Okay. So, this is our function that we call it as pi surface. With this, first we need to find gradient pi. Then, after finding this, they have given a specific point. So, for those values, after finding the gradient pi, we want to substitute the value of x equal to 1, y equal to minus 1 and z equal to 2. Then you will get gradient pi at the given point x, y, z. After finding this gradient pi, let us consider as 1. Now, we have to find the norm of gradient phi. That means a square root of each element we have to square, and we will sum up the elements under the square root. That we call it as norm gradient pi. Okay, so let us begin. So let us take this given function as pi. So I am taking this 4 to that side, it become minus 4. I am considering this as surface pi x, y, z. On the next, we know that gradient pi will be dou pi by dou x I vector plus dou pi by dou y j vector plus dou pi by dou z k vector. So this is our pi. First we will find dou pi by dou x. So we want to differentiate this function with respect to x. So it will be 2x, then y. The rest of the thing will be 0. Then if I find dou pi by dou y, here it will be 0 with respect to y, x square becomes 0, and here it become y will be disappear with respect to y. If I differentiate this function, there will be x and the remaining it will be 0. Then we need dou pi by dou z. So definitely it will be 2z. With this, we will substitute these values and then we will get the gradient pi. So this is what we have calculated previously. Then we will substitute in this. So what will be the resultant here? After substituting this, our gradient pi will be 2x plus y I vector plus x j vector plus 2z k vector. This is our gradient pi. So at last we want to find at the point x 1 minus 1 2. So our gradient pi will be 2x plus y I vector plus xj vector plus 2z k vector. So for each of the value y, x, z, okay, we want to substitute the values. So here what they are doing, simply I am equating the value of x, y, z in this directly, and after finding this we will find the gradient pi at the point 1 comma minus 1 comma 2. Now here I have written gradient pi directly. If I need, if it is of without the point, now this will be the gradient pi. Okay, so the both are same. Either you can first to find the gradient pi function, then you can substitute the values of x, y, z, or else you just substitute the values of x, y, z directly here, and then you will get this value. So our gradient pi will be this. I will try this here. Our gradient pi at the point x, y, z, it will be 2x plus y into I vector plus x j vector plus 2z k vector. So what is our point? 1 comma minus 1 comma 2. 1 comma minus 1 comma 2. So at the point gradient pi 1 comma minus 1 comma 2. So if I substitute x equal to 1, and I will get 2, y equal to minus 1 minus 1, I vector plus x will be 1. So j vector plus 2 2's are 4 k vector. So this we got I vector plus j vector plus 4 k vector. This is what the same. Okay. So we find the gradient pi. I may take this as 1. On the next, to find the n cap, we need gradient pi and also norm gradient pi. So now we are going to find this. Okay. So how do we find this value? Simply, this is our gradient pi. I will square up each of the vectors. 1 vector plus 1 vector plus 4. Okay, so I am squaring up each of the element. 1 square plus 1 square plus 4 square. I am taking a square root. It will be a gradient pi the whole norm. So it will be of square root of 18. Therefore, n cap will be I vector plus j vector plus 4k vector by square root of 18. This will be the unit normal vector for the given surface. Have you understood? Okay, on the next, similar problem. Here I have given x square plus y square plus z square equal to 1. This is our surface. I may take this pi. So on the next line, I will take this as a pi. And they have to evaluate this function at the point 1 comma 1 comma 1, and then we have to find the unit normal vector a similar way. I may take this as pi. If I bring that 1 to next time, it will be of pi. Next we are going to find gradient pi. It will be dou x by dou pi by dou x I vector plus dou pi by dou y j vector plus dou pi by dou z k vector, and we will find that individually. Dou pi by dou x. If I differentiate this function, I will get 2x. If I differentiate this function with respect to y, it will be 2y. If I differentiate this, here it will be 2z. Both on all the values, you will get 2 as a common. So here it will be 2 into xi vector plus yj vector plus zk vector. Okay, this is will be gradient pi. Gradient pi at the point 1 comma 1 comma 1 will be 2 into I vector plus j vector plus k vector. This will be the gradient pi at the point. If I find gradient pi, the whole norm, it will be 2 square plus 2 square plus 2 square. Okay, so it will be of 4 plus 4 plus 4. Okay, 8. Then here it will be 12. Square root of 12 with the norm of gradient pi. So let's see, 2x, 2y, 2z. And here this will be gradient pi at the point 1 comma 1 comma 1. And if I find this, here it will be root 12. It can be written as 2 root 3. And n cap will be 2 into I vector plus j vector plus k vector divided by 2 root 3. Okay. So if I class over 2 on each of the value 2, it will be the final answer.